sometimes the use of the Newton's laws are quite simple, even for some systems that seems a little bit difficult. And the important part is to think in terms of a system and not in terms of objects. So this is what we're going to do in this exercise. We're going to use a dynamic system to find the acceleration of the system in a simpler way. Okay, so this is the system you can see here, and it's like essentially just two masses that are connected with a string. Okay, so you have two masses connected with a string, and here is the thing that we need to determine what is the acceleration of the mass m, of this mass. Okay, what is the acceleration of this mass? This is the question. Okay, so if you apply like the Newton dynamics for each body and free diagram body for each one, so you're gonna have like a system of equations and a lot of information. Okay, but we're going to try a different way to solve the situation by using the dynamic system. And using the dynamic system is this form. If you notice, the string is just like a constraint that keep both bodies together. Okay, so what we're going to do is to take the system, including the string, and we're going to think in terms of the second Newton's law that established that the net force is equals to the mass times the acceleration. Okay, but what's going to be the net force? So we're just going to take into account forces that are outside the system. Okay, the external forces to the system. In this case, the force of the string, the tension here of the string, that is the same tension here of the string upon the mass m, or the capital M mass, is not going to be an external force. Okay, it's part of the system. The dynamic system is the two masses and the string. Okay, so the external forces of the system will be first the weight here of this mass. Okay, the weight of this mass, and maybe friction. Okay, but we're going to suppose that there's a frictionless subsurface. So just in this case, we're taking into account the external force weight. So what we have to write is just the external force, that is mass over weight. Okay, this is the force in the direction of the motion. Okay, we're assuming that this system is moving in this direction. Okay, because there are another forces that are external. For example, the normal force here is external, but it's not in the direction of the motion, so we're not going to take it into account. And the other is, for example, the weight here over the mass, the capital M mass, but again, it's not in the direction of the motion, so we're not going to take it into account. We can take it into account to determine the normal, but that's part of another exercise. In this case, so the only force in the direction of the motion is going to be the weight of the mass, and the system mass is not going to be just m, just the mass that is moving here, but also the mass, the capital M mass. So we're going to have capital M mass plus small mass equals the acceleration. So if you can notice, that is so simple now to determine the acceleration. So the acceleration of the system is just going to be small mass over the sum of the masses and the gravity acceleration. Okay, so as we're using just one direction, we can just take away the vector sign, and then we have the acceleration of the system. And you can see that it's quite simple to get the acceleration of the system instead of having like free body diagram for each block and then determine the acceleration by solving the system of equations. Okay, so as you can see, we just have to take forces in the direction of the motion. In this case is the weight, like the force that is pulling the objects, equal to the masses that you're moving in the system, m, capital M, times the acceleration, and then you can find the acceleration. You know, so it's pretty simple, right? You just need to learn how to apply the Newton's law, and that's it. So I have nothing else to tell you. Just subscribe to the tube, tell me if you understand the information, tell me if you like it, and remember that you can follow me in all my networks as HugoFim. So see you in the next video. I hope you enjoy it, and we can talk about this exercise later. Goodbye.